So on Friday, we talked about how to get from log form into exponential and exponential into log form. And then from there, how you can simplify these expressions using some simple mental math. All right, so number 1 says change 6 to the 4th equals 1,296 into log form. So who can tell me what they got for that? Go ahead, Ben.
Log 6, 1,296.
Okay, log, so 6 is the bottom right. Log base 6 of 1,296 equals 4. Good. Raise your hand if you got it right. Okay, good. All right, now change log base 27 of 9 equals 2/3 to exponential form. So now you're going in the other direction. So what's the large number? 27. What's the exponent on the 27? 2/3 equals 9. Good. Remember, the little guy comes over, picks up the one that's by itself, and then leaves the rest of the number by itself. Okay, number 3 says calculate the following using mental math. So what did we say was the base if it's not there? 10. So this is really log base 10 of 100,000. So how do I get 10 to become 100,000? 10 to what power is going to give me 100,000? Good. So the easiest thing about tens is you can just count your zeros, right? If it's 10, it's 1 0, which would be to the first power. 100 is 2 zeros. That's the second power. 1, 2, 3, 4, 5 zeros means I have to raise x to the 5th power to get it. So 10, you can count your zeros. All right, number 4, we're saying what power do I raise 64 to get it to be 8? So what do I have to do to 64 to get it to 8? Good. So it's square root, right? It's the square root of 64, and that square root is 1/2. And then the last one, log base 3 of 1/27. I'm saying what power do I have to raise 3 to get it to be 1/27? Good. So the negative brings it to the bottom, and then to get from 3 to 27, I'd have to multiply it by itself twice. So 3 times 3 times 3, which would be -3. Questions on any of those? So there's like one of each of those or two of each of those for your quiz tomorrow. Okay, so now let's finish the notes from Friday. So we're continuing 4-3. So we talked about inverses just as the bell was ringing the last time, okay? And we said that the log is the inverse of exponential, and exponential will be the inverse of log. So this is supposed to be 2 to the x. But basically, y equals 2 to the x is, if that's my initial function, then the inverse is y equals log base 2 of x. So if I took that and put it into an exponential form, then I would get the inverse. So the initial function, if I were to graph my y equals 2 to the x, is this blue graph here. And then if I took and switched all my x's and my y's, I'd get the inverse, which is now the graph of the log here. And then just like all the other inverses that we did in the first section, domain and range, we just switch it. So if I have domain and range of my initial function, and then I want to find the domain of range of the inverse, all we have to do is switch the function, switch the domain and the range. All right, so there's 2 ways to graph log functions. The first is to graph the exponential functions and then switch the x and y values, which is actually what we're going to do with this section. And then there's also, like if I just said to find y equals log base 2 of x, if I asked you to graph this, then you can get it into exponential form and plug in for the y values. So we'll eventually get to that. We're not going to do that method yet. What we're going to focus on in this section is the first. So you'll see stuff like this example, which is actually going to kind of guide you right. It says use the x and y or x values to graph the function and its inverse, and then describe the domain and range of the inverse function. So I told you if you were going to have a base that's in decimal, you were going to have what? A calculator, right? So you can take yours out. If you have them with you, take them out. If it was the base, so on your quiz, which you won't have your calculator for, the base would be a fraction. So I can rewrite this as a fraction if I wanted to. I can make that 5/4 and then solve it without the calculator. But if you had something like this, like for your test, you would have your calculator. So I'm going to set up a t-chart in which my y values are -2, 1, 0, 1, and 2. And then I'm going to plug in each of those values. So 1.5, or 1.25, sorry, to the negative second is 0.64. And then I do 1.25 to the negative first. Which is 0.8. And then 1.25 to the 0, which is what? What's anything to the 0? 1. And then 1.25 to the first, which is what? 1.25. And then 1.25 to the second. Which is 1.5625, but I'm just going to go 1.56. Everybody with me so far? So we took each of those points and plugged it in. Make sure you know how to do this with a fraction without without a calculator, right? If that was like 5/4, then I should be able to do each of these as well. Okay, now I want to graph the function. All right, so I've got -2 and 0.64. So I'm going to go -2 and a little past halfway, but this is not, I'm going to have to approximate this. And then I've got -1 and 0.8. -1 and 0.8, which is bigger than 0.64. And then 0, 1. And then 1, 1.25, and 2, 1.56. So because this is exponential, I know it's going to eventually increase and rapidly. So you can draw it as though it's an exponential, but make sure you pass it through the points that you're given. So it shouldn't be a straight line because those little points won't make a line. And then you have to know that exponential means it's going to increase fast like that. So eventually it's going to come up and start curving. How do I graph the inverse? Switch my x and y's. So now my x's, well, my y's are -2, -1, 0, 1, and 2. And my x's are 0.64, 0.8, 1, 1.25, and 1.56. So 0.64, -2. 0.8, -1, 1, 0, 1.251, and 1.562. And then remember, if I had drawn that line through the y equals x, so straight through the middle of quadrant 1 and quadrant 3, I should be able to fold these over and they should overlap. That's how I can make sure that I graph them correctly. Questions so far? Okay, so now what's domain and range of my first function? What's the domain of my initial function? It's the smallest x. -2. What's the biggest x? 2. And the range, smallest y, 0.64. And the biggest y, 1.56. So then how do I get domain and range of my inverse? Just switch it. So domain is 6, or 0.6, less than or equal to x, less than or equal to 1.5, 6, and then range, -2 to +2. So again, it kind of like baby steps you into solving or plotting this graph, okay? But really this would be log of 1.2x, log of base 1.25 of the x. That's how it would look if I actually graphed it, okay? But you're getting that step by step. So here's the points, plug them in, find your graph of your initial function, and then find the inverse. You're going to switch the x and y's, plot your new points, and then find domain and range of each. Yep.
That's like 0.64. That's like exact.
No, I mean, you're even like 0.6. Like, I know it's a little bit bigger than half. It doesn't have to be perfect. There's no way. I'm not going to, like, make you measure that line and divide it into tenths and then go up 6. Like, I'm not going to be that picky. But I know it's around a half, that you can kind of eyeball it from there. All right, you try it. Notice that this time, my base is a what? Fraction. So try to do this without your calculator. All right, so what's 1/2 to the -2? What's that negative do? It flips it, so the 1/2 becomes 2 over 1, and then 2 to the second would be what? 4. 1/2 to the -1, so it's going to flip it again, except that this time it's to the first power, so this is 2. 1/2 to the 0 is 1. 1/2 to the first, 1/2, and 1/2 to the second, 1/4. So this is a couple of you got this wrong on the last test. Make sure you know how to do an exponent times, a fraction times a fraction. So if it's 1/2 raised to the second power, this means that it's 1/2 times 1/2 multiplied straight across, and I get 1/4. So same thing as squaring both the top and the bottom. That's 1 squared over 2 squared, which becomes 1 over 4. So whichever way it makes sense to you, make sure you stick with it. Okay, then it says graph the function. So I'm going to graph the function. So -2, 4, -1, 2, 0, 1, 1 and 1/2, and 2 and 1/4. So it should, again, make sense, because if it's a fraction, is it growth or decay? It's decay, so this should have made sense that this goes down as you move to the right, unlike the other one. That was bigger than 1, so that was growth. Okay, so then this time I want to switch my x and y's again to find the inverse. So I'd get 4, 2, 1, 1/2, 1/4, and my y's are now my x's, or x's are now my y's. And then I'm going to plot those points. So 4, -2, 2, -1, 1, 0, 1/2, 1. And 1/4, 2. And again, if I drew that line straight through the middle of the middle of quadrant 1 and 3, and folded my graph, it should overlap. All right, so what's the domain of my initial function? What's the smallest x? -2. Biggest x, 2. Range, and note this time range is not in order, so sometimes it's not in order. You got to just look for it. What's the smallest y? 1/4. And the biggest y? 4. Okay, and then the domain and range for the inverse, just switch them. So 1/4 to 4, and -2 to 2. How many of you were either completely right or on the right track at least? Okay, any questions on it? All right, so finding logs using the calculator. So again, if you didn't take it out already, you want to take it out. Remember, the log button itself is log base 10. So So if you'll locate your log button on your calculator, there should be log and then the exponent, the little thing above it should be 10 to the x. Does everybody see their log button on the calculator? Yeah, everybody see it? Anybody need help finding it? Should be yours right there. So that one has ln and log. So hit that button and now hit it twice, like double click it. There you go. Okay. So some of your calculators will actually, which is that one, will actually let you change the base on a log, like so that if it said log base 3 of 9, that you could actually change that base to be 3. Most of them don't. And so if I said to find log of 9, it would be log base 10 of 9. So the log on your calculator, unless it lets you change it, is always the log base 10. So this is just it's kind of like a word problem involving the calculator. It says that given that the pH is the negative log of hydrogen, find that the pH of each substance listed. So in the left, obviously, you've got your substance. In the middle, it's the hydrogen molecule per liter. And then on the right, you're trying to find pH. So all you have to do is take each one of these values and plug them in the place of the H. So I would say that the negative log of 0.12, there's 1, 2, 3, 4, 5, 6 zeros there. 1, 2, 3, 4, 5, 6, 2, 5. And then just hit enter. So negative comes first, log, and you want it to be log base 10, 1, 2, 3, 4, 5, 6 zeros, 2, 5. And I get 6.6. So anybody in chemistry? Have you done logs yet for pH? You will this year, so you'll do logs. That's the good thing about the overlap. Okay, you'll do logs to find the pH. Tomatoes would do the same thing. So negative log 0.123406316, and I get 4.5. And then lemon juice, negative log 0.0063, and it's 2.2. So you would never get one of those without a calculator. Those won't be on your quiz, okay? But just so you can see, there's some real world application there that you do use logs outside of here. And make sure that you know how to use that calculator. So log base 10 would be the button you're using. All right, questions overall from 4.3. Okay, so 4.1 to 4.3 is quiz tomorrow. 4.1 to 4.3. So in 4.1, go through what's on there. In 4.1, this is when we did growth versus decay. If it's greater than 1, then it's growth. If it's in between 0 and 1, then it's decay. So if it's a fraction that's less than 1, something like 3/2 is bigger than 1, that would be growth. And then from there, you just had to, find out your actual trig function. So write a growth or decay model. And then it'll ask you predict how much it would be after year 5 or something like that. That would be, so your quiz you won't need that calculator for. Actually. Yeah, so on your growth decay question, you will get your scientific calculator, not graphing, okay, but well, actually, it doesn't matter. You can use either one. You just won't need a graphing calculator. So this question, you will use your calculators. Okay, that's where you set up the growth model or decay model and then figure out where it would happen given a certain time period. And then we went into inverses and relations, 4.2. And for these, you were taking a set of points, finding the points of the inverses, so switching your x and y's. So if I gave you x and y, just like we did before, let's say I just gave you these 3 points, and I gave you this was 3, and this is 5, and this is 7. And then I asked you to find the inverse. So we just practiced this, but all we would have to do is switch these. So this would be 3, this would be 5, this would be 7, and this becomes -1, 0, and 1. And then make sure you know how to find the domain and the range of each of those, and would know how to graph each of those. Okay, so that was in 4.2. And then also in 4.2 was finding the inverse from an equation. So what were the steps here? What's the first thing you have to do? What do I do with that f of x? What's the same thing as f of x? Y. So I make that y. And then to find the inverse, switch the x and the y. So this becomes x equals 3y minus 7. And then solve for your new y. So how you solve is different because it depends on how you're setting up your, what kind of equation it is. This time I just have to add the 7, so x plus 7 would equal 3, y, and then divide by 3. And then that last step is to get it back in terms of the f of x, except that it's not just f of x anymore, right? How do I note inverse? Good, f -1 of x. X plus 7 over 3, which I'll take that answer, or you could split it. Either one works. Okay. So step 1, replace the f of x with the y. Step 2, switch the x and the y. Step 3, solve for that new y. Step 4, put the -1 back in place of the y. Questions on inverses? Okay, and then everything in 4.3, which is what we just did this morning, which is finding the log, exponential to log, or exponential, or log to exponential. So converting it, like 2 to the 4th equals 16. In log form would be log base 2 of 16 equals 4. So know how to go back and forth between those. And then the simple mental math ones, like log 3, base 3 of 27. So what do I have to raise 3 to get to 27? 3, this would be 3. Something like that. And then the stuff we just did the notes on. So figuring out your points. If I give you these 5 points, plug them in, get the y's, graph it, switch them, find domain and range of each one. Okay? Yep.
Are we going to have our calculators for the whole thing?
No, just the growth and decay ones at the very beginning. Does that make sense? Yeah? So everything else would be fractions and not decimals to raising to the power. Okay? So I was trying to